Today we're going to be looking at another way to solve a system of equations, and the method we're going to be using today is substitution. Now, I've listed the steps that we're going to use. They will become more meaningful as we do some problems, but step number one is to solve for one variable in at least one equation if necessary. Number two, substitute the resulting expression into the other equation. Number three, solve that equation to get the value of the first variable. Number four, substitute that value into one of the original equations and solve. Number five, write the values from steps 3 and 4 as an ordered pair. Now, as I said, this will become more meaningful as we actually do some of the problems. Our directions here are to solve each system by substitution. And the first system is y equals 3x and y equals x minus 2. Now the first step was to solve for one variable if necessary. Now if you notice, both of these equations have a variable that's isolated. They're both solved for y, so we can skip that first step. Now the second step is to substitute an expression into the other equation. Now if y equals 3x in the first equation, there's no reason why we can't substitute it into the second equation. So we've got 3x equals x minus 2. Now what we're going to do is solve that equation to get the value of x. So we're going to subtract x from each side. You notice everything's written in terms of just one variable, and that's x. So we've got 2x equals negative 2. Divide each side by 2, and x equals negative 1. Now, what we're going to do is take that value of x equals negative 1, and we are going to substitute that value of x equals negative 1 into the first equation. So we're going to substitute that into y equals 3x. You notice that was our first equation. We were using the second one when we were solving. We're going to substitute it back into the first equation. So we've got y equals 3 times negative 1. So y equals negative 3. So we've got our values for x and for y, and we write our answer as an ordered pair, negative 1, comma, negative 3. And there is our final answer. So before, when we solved systems by graphing, we graphed each line and found out where they met. You're basically still finding out where those two lines meet, except you're doing so without actually having to make the graph. You're using this method called substitution. Now let's take a look at this next system. We have y equals x plus 1 and 4x plus y equals 6. Again, our first step would be to solve for a variable. However, we don't have to do that. We've already got y isolated in the first equation. So we're going to start by taking that value that y is equal to, x plus 1, and substituting it into the second equation in place of y. So we have 4x plus x plus 1 equals 6. Now we're going to go ahead and solve that, which is our next step. So we have 5x plus 1 equals 6. Subtract 1 from each side, and we have 5x equals 5. Divide each side by 5, and we have that x is equal to 1. So now we know what x is, and the way we're going to find out what y is substitute our value that we just got for x into the other equation, which is actually the first one, into y equals x plus 1. So we have y equals 1 plus 1, or in other words, y equals 2. Therefore, our ordered pair is 1, comma 2. All right, now moving on to our next equation our next system of equations that we want to look at is x plus 2y equals -1 and x minus y equals 5. Now our first step is to solve for one variable if necessary, and it is in this case. We do not have a variable that's isolated. Now what I would do is I would pick the easiest one possible, and I would solve for that variable. So for example, I'm looking at these two equations, I'm thinking, oh, well, I could solve for x in the second one just by adding y to each side. So I'm going to pick that one. It really doesn't matter which one we choose, whether we solve for x or for y, but just pick what's easiest. And it doesn't matter which equation you use first. So I'm going to solve for x in x minus y equals 5. So I want to get x alone, so I'm going to have to add y to each side. And I end up with x equals y plus 5. Now, that's very important. I'm actually going to circle it because that is a very important expression. Now, what we're going to do is we're going to substitute that expression into the other equation we haven't used in place of x. So going back to the first equation, which we had not used, I'm going to put y plus 5 in place of x. So I've got y plus 5 plus 2y equals -1. And now I'm going to solve it for y. So combining like terms, I have 3y plus 5 equals -1. Subtract 5 from each side. So I'm going to move up to the top. I have 3y equals -6. I'm going to divide each side by 3. And I have y equals -2. So now I'm going to circle that because that's half of our ordered pair. Now we still have to find x. Now to find x, we're going to substitute y equals -2 into an expression for x. Now we can go back to one of the original equations we started with, or we can go to the expression we used that we found, that x equals y plus 5, right in our first step. And I would recommend doing that. So we're going to have x equals -2 plus 5. And that means x equals 3. So we end up with the ordered pair of 3, -2. And that is our solution for the system. Now, moving on to problem number 4. We have y equals x plus 3 and y equals 2x plus 5. We do have a variable that solved for us, and actually we have one in both equations. The y is isolated in each one. So we can just go right ahead and substitute the value x plus 3 into y in the second equation. So when we do that, we have x plus 3 equals 2x plus 5. So we want to get all the x's onto one side, so we subtract x from each side. And we have 3 equals x plus 5. We want to go ahead and get x alone, so we're going to subtract 5 from each side. And we have -2 equals x. So there's half of our ordered pair. Now we would like to find out what y is, so we are going to substitute our answer for x equals -2, into the equation that we have not used. And we were using the second equation the last time, so we're going to plug it into y equals x plus 3. So we have -2, y equals -2 plus 3, so y is 1. And our ordered pair turns out to be -2, 1. Now, moving on to our next equation. Actually, number 5, I would like you to try on your own. So that's something I'd like you to try for the next class. And let's move on to the next equation on our next page. Number 6, we have 2x plus y equals -4 and x plus y equals -7. We need to solve one of these equations for a variable. The variable is not isolated at this point, so we are going to have to solve for one of them. Pick whatever is easiest. I would actually go with probably the second equation, and you can solve for either x or y. I'm going to try to solve for x. So let's solve x plus y equals -7 for x. So we'll just subtract y from each side, and we end up with x equals -y minus 7. Now, as you know, you have to take that answer for x and plug it into your other equation. Now, the other equation would actually be our first one. So we are going to actually say 2 times our expression for x. So that's 2 times -y minus 7. Now, we have to put that in parentheses because we're multiplying that expression by 2. And then we're going to add our plus y equals -4. To solve it, we have to start by distributing. So we have -2y minus 14 plus y equals -4. -2y plus y gives you -1y minus 14 equals -4. Add 14 to each side. We have -1y equals 10. I'm going to move up to the top here. So we have -1y equals 10. Divide each side by -1. And we have y equals -10. So there's our first value, or our one value of the ordered pair. Now the thing we have to do is substitute y equals -10 into the other expression. So we're going to go ahead and, since we've already developed an expression for x right over here, which I'm pointing to, x equals -y minus 7. Let's go ahead and just plug that right in there. So we're going to have x equals negative, and then we're going to plug in -10 minus 7. Well, -10 gives you +10 minus 7. So x is 3. And so our ordered pair turns out to be 3, -10. I'd like you to look at number 7 on your own and at least get started on that one, trying to solve. And the very last thing that we want to do is let's go ahead and take a look at this next word problem. It says Jenna is deciding between 2 cell phone plans. The first plan has a $50 sign-up fee and costs $20 per month. The second plan has a $30 sign-up fee and costs $25 per month. After how many months will the cost be the same, and what will the cost be? If Jenna has to sign a 1-year contract, which plan will be cheaper? So let's just see if we can set up the equations. Our first plan, it looks like the cost, we'll have y represent the cost, is going to be $20 times your number of months plus the $50 sign-up fee. The second plan has a $30 sign-up fee and costs $25 per month. So if y is the cost and it's $25 for each month, we're going to have y equals 25x plus that $30 sign-up fee. And I'd like you to go ahead and finish up the problem. Thank you very much.